The third lecture expands on different sanitation technologies, particularly focusing on Ventilated Improved Pit IP latrines and odorless earth closets, which are low-cost solutions often used in developing countries. Here's a long-form explanation of these concepts based on the lecture materials. 1. Ventilated Improved Pit latrine is an upgraded version of the traditional pit latrine. Its primary advantage is odor and insect control, achieved through a vent pipe that ensures airflow and minimizes the escape of odors and flies. Components of VIP latrines: pit, a dug space to collect human excreta; cover slab, a protective slab to cover the pit, preventing direct exposure to waste; vent pipe, a large pipe, 150 millimeters diameter, that allows for continuous airflow, enhancing the decomposition process and preventing the buildup of gases. Fly screen, a screen that prevents flies and mosquitoes from entering the vent pipe. Types of VIP latrines: single pit VIP latrine, typically designed to last 10 years. This version uses one pit. When the pit fills, users must either construct a new latrine or empty the existing pit. However, emptying the pit can pose health risks if done manually. Twin pit VIP latrine. This design involves two pits, one of which is used while the other rests. After one pit fills, it is sealed and left for decomposition while the second pit is used. After some time, the first pit's contents can be safely removed. This cycle can continue indefinitely, making twin pit systems more sustainable. Advantages of VIP latrines: minimal water usage, making it suitable for areas with scarce water resources. Low cost and effective in odor control, improving the user experience. Reduces the presence of flies and insects, which are common vectors for disease transmission. Disadvantages: the system requires proper ventilation, which means the vent pipe must be at least 0.5 meters higher than nearby buildings. This makes it less ideal for densely populated urban areas. If the airflow is not well maintained, the system may not function as intended, especially in regions with unfavorable climates. There's also a risk of groundwater pollution if the pit is not properly designed. 2. Design considerations for VIP latrines. Design life. Single pits are usually designed to last for 10 years, while twin pits have a shorter cycle of 1 to 3 years. Pit dimensions. The pit cross-section should be no larger than 2 mm² to avoid complex and costly slab construction. Vent pipe. Typically made of PVC or brick, the vent pipe needs to be at least 150 millimeters in diameter to ensure proper airflow and must extend 500 millimeters above the roofline. Fly screens. These are essential for keeping out insects, and they should be corrosion resistant and able to withstand intense weather conditions like rain and sunlight. Odorless earth closet is another variation of the VIP latrine, designed to further minimize odor and insect nuisance. It involves offset pit. Unlike the VIP, the pit in an ROEC is completely separate from the superstructure and is connected via a chute. Ventilation stack. Similar to the VIP system, a ventilation stack helps create airflow that removes odors and discourages insects from entering the latrine. Advantages of ROEC. It allows for larger pits, which can store more waste. Pits can be emptied more easily, making maintenance less burdensome. The separated design makes users feel safer and is generally more aesthetically pleasing. Disadvantages of ROEC. The chute connecting the pit to the latrine can easily become dirty, leading to potential odor issues and fly breeding. Regular cleaning of the chute is required to prevent these problems. As with VIP latrines, there's a risk of groundwater pollution if not properly designed. 4. General advantages of improved sanitation systems. Both VIP latrines and ROEC offer several significant advantages over traditional open defecation and simpler latrines. Health benefits. These systems reduce exposure to human waste, limiting the spread of diseases caused by pathogens in fecal matter. Environmental impact. Proper waste management reduces groundwater and surface water contamination, a significant issue in areas with poor sanitation infrastructure. Economic benefits. The low-cost construction makes these solutions accessible to low-income communities, while their longevity ensures they remain functional for extended periods with minimal maintenance. Conclusion. Both the VIP latrine and ROEC represent significant advancements in low-cost sanitation technologies, especially in regions with limited access to water or financial resources. While each system has its challenges, like the potential for groundwater pollution and the need for regular maintenance, their benefits in terms of health, safety, and environmental sustainability are considerable. When designed and maintained correctly, these systems offer practical, long-term solutions for improving sanitation in developing areas.